Hello everyone, in this video I will explain what are significant digits and how to identify the significant digits in a measured value. What are significant digits? Significant digits are the trustworthy digits in a measured value indicating the precision of calculated or measured value. So simply it tells about the precision of measured value. Significant digits, also called trustworthy digits, consist of all certain digits and one uncertain digit. Certain digits means digits measured exactly. Uncertain digit means digits measured with uncertainty or it is estimated. Let us consider an example of measurement of a pencil length. In this example, the measured length of the pencil is 12.34 centimeter. That is recorded up to two decimal places. Okay. Now question is how many significant digits are in the measured length 12.34. In the figure, you can see that pencil length is 12.3 plus. You can see here it is 12 and it is 1, it is 2 and it is 3. Okay, so measured length is 12.3 plus something. Means it may be 12.31, it may be 12.32 or 12.33. It can be up to 12.39, which is the meaning of 12.3 plus something. So here digits 1, 2, 3 are directly measured using scale with certainty. Okay. Therefore, we call these digits are certain digits. But last digit cannot be measured by given scale. It can be measured by own judgment. So it can be any digit from 1 to 9. Also, you can see here in the figure 12 is measured. This is 12. This is 12.1. This is 12.2, 12.3. But last digit is not measured. You can see in the figure. As pencil length is measured and recorded 12.34. Okay. That means last digit 4 is not measured by the given scale. It is estimated or measured with uncertainty. Hence, digit 4 is the uncertain or estimated digit. So here we have certain digits are 1, 2, 3 means total 3 certain digits and uncertain digit is 4 means total 1 uncertain digit we have. So total number of significant digits are certain digits plus uncertain digit that is 1 means total significant digits we have 4. Now how to identify significant digits. The most important point to remember is about the digit 0. A 0 digit is significant if it is actually measured and tells about precision of the measured value. Here, measured means measured directly by scale with certainty or measured by rounding with uncertainty. A 0 is not significant if it is used to shift the decimal point only. So remember that all non-zero digits are significant, means all digits from 1 to 9 are significant. So for example, the measured value 357 has three significant digits and the value 81.29 has four significant digits. If we talk about certain digit and uncertain digit in number 81.29, so Here 8, 1, 2 are certain digits and 9 is uncertain digit. So total 4 significant digits we have here. Second point is zeros between non-zero digits are significant because they are part of the measured value. Example 1002. Here zeros between 1 and 2 are significant. So total significant digits are 1, 2, 3, 4. So 4 significant digits in 1002 and in 2.005 we have 4 significant digits. Okay. Now third point is trailing zeros in a decimal number are significant. So zeros at the end of a decimal number are significant because they indicate the precision of the measurement. Okay. So in this example in 0.40, this zero is trailing zero. So trailing zero is significant. So total number of significant digits here 2. In 0.400, trailing zeros are 0, 0, this two zeros. So total significant digits are 3. Here these trailing zeros tells about the precision, means it is this value is precise or recorded up to 3 decimal places, we can say. Now leading zeros in a decimal number. Leading zeros in decimal number are not significant because these zeros only help to locate the decimal point in the measured value. Example 0.081. Here this 0 is the leading zero, so this 0 is not significant. So total significant digits are 8, 1, means total 2 significant digits we have. Uh, in 0.0081, these two zeros are leading zeros, means not significant. So again, we have two significant digits, which are 8 and 1. So 0.00081, again, we have only two significant digits. So in all cases, only the digits 8 and 1 are significant. These zeros tell us about the magnitude of the number, not about its precision. Magnitude means how big or how small the number is. Okay, so in all examples, the magnitude of the number changes, but precision does not change. Now, important point is trailing zeros in integers are ambiguous. Ambiguous zeros means zeros could be significant or not. For example, in the measured value 500, trailing zeros are ambiguous. So significant digits in 500 are not fixed. It could be 1, it could be 2, it could be 3. So first case is suppose the true value lies between 499.5 and 500.5. Okay, so true value may be 499.5, it could be 499.6, it could be up to 500.4. Okay, so if we round this value to ones place is this one, in this value ones place is this, and here ones place is this. So if all these values are rounded to ones place, then what we are getting after rounding ones place means it will be, because it is 5, so it becomes 0. 9 plus 1, 10, it becomes 0, which is uncertain digit because it comes after rounding, and this digit becomes 0, this digit become 5. So we are getting 5. Same here, This digit is uncertain digit. It becomes 0 after rounding because here we have 6. This digit becomes 0 and it is also 5. And same here, it is 4. So it remains same. 0, it is 0, it is 5. So you can see here that the measured value 500 is obtained after rounding of the true value to ones place. Clear? So certain digits are 50 and uncertain digit is 0, uh, which is the last digit after rounding. Therefore, total significant digits in this case are 3. Okay, two certain digits and one uncertain digit, total 3. Now assume that true value lies in the range 495, in between 495 and 505. So true value may be 495, 496, 497 up to 504. Okay, up to 504. So in this case, the measured value 500 is obtained when true value is rounded to tens place. Tens place, which one? This is the tens place. So after rounding to tens place, this value becomes 0, this becomes 5, and this it will be the placeholder, it becomes 0. So again we are getting 500. This is rounded to tens place, we are getting 500. This is also 500. So the true value is obtained after rounding to tens place. So in this case, certain digits is only 5 and uncertain digit is this 0. So total significant digits we are getting here 2. And this digit is the placeholder only. This is the uncertain digit. This is certain digit. So total significant digits 2. Finally, suppose the value lies in the interval, lies in between 450 and 550. Okay, so in this case, the measured value 500 is obtained when true value is rounded to hundreds place. Okay, 100 place is this one, and here it is 5. So in this case, we have only one uncertain digit, and there is no certain digit here. So certain digit no, uncertain digit is only one, which is 5. That is obtained after rounding to hundreds place. Therefore, total significant digits we have here 1. So in this example, the measured value 500 can represent 1 or 2 or 3 significant digits, and it depends on the rounding level. That's why trailing zeros in integers are called ambiguous. So friends, if you found this lecture helpful, please like the video, subscribe to the channel, share it with your friends, and if you have any doubt or question, write them in the comment section. Thank you very much.